extremely expensive, a 6-inch reflecting telescope is relatively cheap. You can get a 6-inch reflecting telescope for around about $300, whereas a 6-inch refracting telescope, you're looking into the thousands. Now, then we got what's basically a hybrid style telescope, which is this one here. This is called a catadiopter telescope, and it's hybrid in it's got a lens in the front, a mirror in the back, and then another mirror in the front. You got this lens here, got a mirror here, and if you look all the way back in there, you'll see a mirror at the very rear of it. Oh, not so close. Now what this telescope does is very similar to that. Is light comes in, hits this lens, it focuses a little bit, but then it hits this mirror, which then focuses into this mirror and then back out the back of the telescope, which lets you have the equivalent of a very long telescope in a very short package. The length of the light path in this scope is 1,500 millimeters, whereas I think this is 700 millimeters. So this telescope right here, if you were to take that mirror out and let this rear mirror focus at a point 1,500 millimeters that way, or 1.5 meters that way, you'd have a small dot. This is roughly half that distance.
If this is so much better, how much more expensive is it compared to this?
This telescope here is about $900.
And it's still better than that.
Oh yeah. Well, better at what you can see deep space objects and stuff like that, but for planets and other things, you can see just as well in here. You can see more stuff with this one. Plus, this one also has another little trick up its sleeve. Please don't lean on the table.
I guess you can.
This one, once you get it aligned, if I wanted to go to the moon, I click solar system, tell it I want to see the moon, which is not upright yet, so it's not. Well, let's say we want to see Jupiter. Let's take me to Jupiter. And it goes and finds Jupiter.
Give me my money.
We'll just stay for a little bit longer. Here's some. Now we talked about what I was doing. Was I revolving or rotating?
Revolve.
I was revolving, right? This is what? What do you call that?
Rotating.
That's rotating, right? Okay. Now, what I want to do is, it turns out for some pretty interesting reasons that y'all may or may not study, the moon rotates one time for one trip around the Earth, right? So it does this. I want to do this. So right now you're looking at the Rawlings, right?
Yeah.
Okay, and then there's like a official label on this, like okay baseball use over here, right? So there's some initials here, Rawlings, nothing here, right? So what happens? You guys watch this because again, y'all are off in a spaceship watching this. What happens is as I go around, it makes one complete rotation as it makes one complete trip around the Earth, right?
So we see all the time the near side of the moon.
We see the near side. So, but watch what happens from your perspective. See how you don't see anything now, right? Because I want you guys to see that it's actually rotating. So as I go around, now y'all are looking at the Rawlings label, right? And then you're looking at nothing, the other side of the label. And now y'all are looking at that official stamp on it. And then you're back looking at the nothing you were looking at to start with, right? So that's one complete rotation. Nothing, Rawlings, nothing, official stamp, back to nothing, right? Right, yeah. That's so it is rotating, right? Yeah. Now you tell me what you see on Earth. So here we are. We're rotating. Y'all see it rotating. What are you looking at? What were you looking at? I'm sorry. What were you looking at before? Looking at Rawlings, right? So over here, rotated around. What are you looking at? Rawlings. Rotated around. What are you looking at? Keep rotating. What are you looking at? So what are you looking at the whole time? Right. So because it rotates one time for every trip around, we have the same side facing toward us the whole time. So Rawlings. Which actually makes it kind of neat for us amateur astronomers because when they draw a map of the moon for us to, that we use to look at, they only have to do half the moon because we only see half the moon when we look at it with our eyes or binoculars. It's kind of a downer because you can't see what's on the other side. If there isn't official initials on the back side of the moon, we wouldn't know it because it would be facing us all the time. Unless you go there. You got to go there, right? So we talk about business stuff over here. So if you look, we have a near side of the moon and a far side of the moon. But if you look, when the sun's over here, now the far side of the moon's lit up, right? So they're having daytime. But then as it rotates, the sun's setting on the far side, the sun's rising on the near side. Now the near side's fully lit up and the far side's dark, right? So if you're on the moon, you get daytime, nighttime, daytime, nighttime, daytime, nighttime. It just takes a month to have a full day go by. For the sun to come up, however it's have it at nighttime. Like so can you imagine like your watch, right? You wouldn't fit 24 hours. You want to
talk a little bit about the solar system, maybe some satellites that are floating around, some of the space probes, and anything that comes to mind while we're waiting for the sun to get lower in the sky and try to darken up. So we can take a look at the moon and hopefully we find Mars someplace hiding around close by. And we take a look at the planet. Essentially, we're going to be talking and I'm interested in the composition of the
Carbon.
Well, that's one of the fuels.
guys, I'm starting the road. Stop the road.
Help me.
First, I want to talk about Pluto. Now, just a few years ago, Pluto was considered one of the main planets. But Yeah, but all these guys, they get together in these conventions and they start discussing stuff, and they decided that Pluto didn't quite meet all the criteria to be considered a major planet. And because of the distance it is from us, we have a difficulty in determining a lot of the composition of it and all. There's a probe en route to it, and it should be there in 2 or 3 years, I think. That will be, go into orbit around there, and then they'll just study it, and then they'll have a better idea of what it is. But right now, they're determined. They classified it as a dwarf planet. Now it's kind of an icy rock, they think. Not really sure until they get there. The inner planets are kind of a rocky planet. The Mercury being the closest in to the sun, it's hard to study it also.
It's similar to the moon.
Well, they've sent some probes there, and they've been photographing it and doing the various scientific calculations that they do to determine the composition and all of, everything they can find out about it. Now Venus, for a long time, there were many probes sent to Venus, but it's being getting back to some of our planets here.
So like
Next. There's asteroids coming all the time.
Oh, yeah.
They've got, if you have a computer and you go up to heavensabove.com, they have a chart on there, and it shows that they're near-Earth asteroids. And so you can tell you how far, this one that's coming pretty soon, I think it's next month or maybe the end of this month. I think it's 45 meters across, which is about 100 feet. It'd make a good sized hole
Well, yeah.
if it hit. But it's not calculated. It should go through or past this.
If it does, it'll probably burn like half of it in the atmosphere.
Not necessarily.
It depends what it's made of.
Yeah, exactly. If it's stone, it could explode, like the one over Russia. That was stone asteroid there that blew up and
Made of
came
ice
in,
and stuff.
destroyed half the forest and half the cities around.
If it was
raining
tungsten,
rock.
we'd be screwed.
Okay.
Let's see. Let's go to
It's
see.
heavier.
I guess we can go to Saturn. Saturn's a unique planet because of the rings. The rings go on an 11-year cycle. They're just coming off a few years ago. They were edge on, which that means when we look at the planet, all we can see is just kind of a line with a ring. As it progresses through its cycle, the rings will tilt, and then we can see more and more of the rings. And there's several probes that have gone to the planet, and some have gone through Saturn, some have gone through the ring itself, and they found it to be made up of rocks and ice crystals and all. And my mind is old and weak, and I forgot which moon it is, but they think there's one that gives off that has ice volcanoes, and they think it's feeding some of the ring. They